The natural world is full of patterns and shapes that are both beautiful and intriguing. One of the most fascinating of these patterns is the fractal. A fractal is a pattern that repeats itself at different scales. It's a mathematical concept that has been used to describe everything from the branching of trees to the formation of galaxies. Take a tree, for example. The main trunk splits into branches, which split into smaller branches, and so on, creating a fractal pattern that is both intricate and beautiful. Fractal patterns can also be found in snowflakes, where the unique formation of ice crystals creates a pattern that is both delicate and complex. The shell of a seashell is also a fractal pattern, with each successive spiral following the same basic shape as the one before it, but on a smaller scale. But fractals aren't just limited to small-scale patterns. They can also be found in the shapes of mountains and coastlines. The coastline of a continent is a classic example of a fractal pattern, with each bay and inlet repeating itself on a smaller scale. And on a grander scale, the distribution of galaxies in the universe follows a fractal pattern as well. Fractal patterns can even be found in the distribution of leaves on a plant. This pattern, known as a self-avoiding walk, allows the plant to efficiently maximize its exposure to sunlight. So whether you're looking at a tree, a snowflake, a seashell, a mountain range, or the cosmos itself, fractal patterns are all around us in the natural world. And they're a reminder that even the most complex patterns and shapes in the world can be understood and appreciated with the help of math and science. One reason is that fractals embody a principle known as self-similarity. That is, they look the same at different scales. This means that no matter how closely you examine a fractal pattern, you'll always find smaller versions of the same pattern. This self-similarity is what gives fractals their incredible complexity and beauty. Take a fern leaf, for example. At first glance, it may seem like a simple, symmetrical shape. But look more closely, and you'll see that each part of the leaf is itself composed of smaller, similar shapes, which are composed of even smaller shapes, and so on, creating a never-ending cascade of complexity.